So I'm going to be talking about the development of a declarative code browser with ixml and XForms and a little bit of CSS. I'll show you the code browser first and then talk about it so you know what I'm talking about it. And then I'll show you it again at the end where you can put it all back together again. So this is the code browser. It's the browser for my implementation of ixml. Is it big enough? I can make it a little bit bigger if you're interested, if that helps. What you see here is a list that it's found. It says here that it's found 91. That's 91 entries, which is either documentation, which is in red, or functions or procedures, which are called how-tos in the language that I've used, ABC. So all of these will unwrap if I click on it, and my fingers are sticky, so not responding well to that. Yeah. So I can unwrap any of them that I want. I can search. So error, for instance, and that will return all the functions that contain the word error in it, or and it's case sensitive. And there are two parts to the system. So there's the bootstrap and the early, and so I can look at either of those in the same way. And I've added a stupid thing that I can change the font, how to display it, but the sans serif is always better. Okay, so that's what we're going to be talking about. And so now I start talking about it. So first to talk about ixml. That's the implementation of ixml, but you also use ixml in order to implement it. So it's a declarative language for transforming textual documents with implied structure into documents where the structure has been made explicit. So it's a stable specification now. Last year came out. There's a community group at W3C, which are all invited to join if you wish. We meet about every 2 weeks. And I should say there's at least half a dozen implementations. Just last week, a new implementation came out. So there's lots of interesting implementations happening. For those of you who don't know ixml, I'll just give you a small example just to show how it works. This is a very simple example. But so I want to transform dates like 3rd of November 2023 into XML, which you see at the bottom there. So I just describe I created data description in ixml that says a date is a day, followed by a space, followed by months, followed by a year. The minuses in front of the strings mean that those don't appear in the final serialization. A day is a D or an optional D. A month is the list. So I've shortened it there, but you do actually have to write all of those out. And a year is just 4 digits, and a digit is between 0 and 9, and an element for D never appears in the output. So feeding that top input through that description gives me that output. There's much more to it, but that's just to give you an example of what it's about and how it works. So how it works is that we have an ixml processor, which is the thing that my code browser looks at, but it takes a textual document in and it puts the same document out, but then as a structured document. So I've used a circle for processors and triangles for structured documents and squares for unstructured documents. Now what you can see there is the description of that language is a structured document. Well, how do I get that? Well, you use the ixml processor twice. You put the description, which is in ixml, but as a textual document, through the ixml processor to get the structured version of it, and then use that structured version to describe the document that you really want to process. So that's the basic process. In fact, there's a bootstrapping process before that, of course, because the description that you write is in ixml, for which uses a structured description of ixml, which we get from the flat version of ixml in a bootstrapping phase. But in fact, the pilot implementation has the definition of ixml hard-coded, as it were, baked in, so we don't go through that bootstrapping phase. We just use an inbuilt definition of ixml in the first stage. So that's why I have two parts. One is the bit that understands ixml, and the other one is the generalized one. So the implementation consists of two parts. The part one reads and parses the ixml description, serializes it actually into a different format, the format expected by part two, and part two then uses that description to parse the text that you're really interested in, the text document, and serialize that as XML. Now, the implementation is written in a very high-level language, interactive language called ABC. It only has 5 data types: numbers, strings, compounds, bags, and maps. And bags and maps are always kept sorted. All data, including numbers, is unbounded and dynamic. So you can have numbers as large as you want. It's statically typed, but without declarations. And in fact, it was the basis of Python. If you see the language, you can see the family resemblance between the two. And that's because Guido van Rossum, who produced Python, he was a programmer on the project when we were producing ABC. And when he moved to a new project for an operating system, he thought he needed a scripting language for that. And so he built a new language that was for operating systems. I mean, much more directed towards system programming, and created Python. Now, there's a basic problem for me, using ABC, is that ixml uses Unicode everywhere, and ABC predates Unicode, and therefore only has 8-bit characters. So when I first started this project, I thought, well, I'm just going to make, since it's a pilot implementation just to get it going, too bad that I can't support Unicode, but maybe I'll rewrite it in a different language later. And I thought that there could be no Unicode in ABC. But in fact, let me just digress for a moment and talk about Unicode, because actually what came out of this was quite interesting for me. So character sets, of course, and I'm talking to the choir here, I understand, are just a mapping from numbers to character representations, and numbers being the code point. First computer I used had 6-bit character set, 64 characters in other words, and had no cased letters. As a result, there wasn't room. ASCII is a 7-bit character set, which gave us 128 characters and therefore cased letters. And then Latin 1 came along and used the spare 8th bit in a byte to give us another 128 characters. But the next iteration was Unicode at 16 bits, and clearly 65,000 characters should be enough for anyone, but then it wasn't. And so they went to currently 21 bits, 10FFFF being the current highest character. That's 1,114,111 characters, and that should be enough for anyone, right? I love that number, 111411. This is a digression of my digression, by the way. It's a beautiful palindromic number, but I've always thought that whoever invented the term palindrome ought to be shot because it's clearly very badly designed. But unfortunately, I discovered yesterday that it was introduced by an English poet and writer, Henry Peacham, in 1638. So he's already dead, so we can't shoot him. But anyway, I have a proposal for a better word than palindrome, and that's word row. I mean, obvious, isn't it? That's the end of my digression, back to the digression. So UTF-8, which is what XML uses, so up to Unicode, all characters fitted in one 8-bit byte. So there was no difference between a character set and a character encoding. But unfortunately, we've discovered that 21 bits don't fit into a byte. So we have to use several bytes to represent Unicode. And originally it was 16 bits, but then UTF was born because of a problem with Unix-like systems, because files on such systems have no metadata for the character encodings. All the files use the same encoding. And so Rob Pike and one other came up with this smart design. It's a variable length encoding of Unicode with ASCII as a subset, so that suddenly all existing Unix ASCII or Unix-like ASCII files were immediately Unicode compliant. So it was in order to make life easier for Unix implementations, really, that they didn't have to do anything special to the existing files. Now, let me tell you about the traditional view of UTF-8 and why I thought it would be impossible to do it in ABC. It's normally sold as a bit-oriented encoding. So each character consists of 1 to 4 bytes, where the first few bits of each byte tell you what the role is of that byte. So each byte either starts a character or is a continuation byte. And when I say the first few bits, I mean there are a number of 1 bits followed by a 0 stop bit. And all the remaining bits in a byte are data. So you count the number of leading 1 bits. And if it's 0, so if the first bit is a 0, that means this byte is a single byte ASCII character. So there's just one byte for the character. If it's got exactly 1 leading bit set, then it's a continuation byte. If it's got 2 leading bits, it's the start of a 2-byte character, and so there'll be 1 continuation byte following. If there are 3 ones at the start of the Unicode character, then it's a 3-byte character, and similarly, if there are 4 ones at the start, then it's 4 bytes with 3 continuation bytes after it. So what you do is you work out how many bytes you've got to look at, and then you concatenate the data bits of so you take off all those leading ones, you can concatenate the data bits of the n bytes to give you the code point. So the problem for ABC is that you can't look at the bits of a character. The characters are immutable and atomic. Oh, well, here I'm saying it. You can't look at the bits. But then I had an aha moment. There are only 256 bytes, and each one only has 1 role. So the bytes 0 to 127 are ASCII. Bytes 128 to 191 are continuation characters. 192 to 223 start a 2-byte character, and so on. And then the last few, 248 to 255, are illegal characters because they've got 5 or more leading ones. So that means that, and I should say the illegal characters are available for a future expansion of Unicode, allowing up to 42-bit representations of characters. So in other words, we could have 4 trillion characters maximum, which should be enough for anyone. You could say, I mean, I could use ixml to describe this if you could have an implementation that was bit-oriented rather than byte-oriented rather than Unicode-oriented. You could say an input is just 0 or more U's, where Unicode characters, where a U is either a U1, a U2, a U3, or a U4. A U1 is a 1 byte, a B1, a U2 is a B2 followed by a B0, a U3 is a B3 followed by 2 B0s, and a U4 is a B4 followed by 3 B0s, and then the B1s are just those characters as I explained. So that's an ixml description of the format of Unicode, which is quite nice. So anyway, my solution was for each byte, and there are only 256 of them, so just an array. Set in the array how many bytes that character starts. So for ASCII, it's just a 1-byte representation. It's 2 for the characters that can start a 2-byte character, and so on, and 0 for continuation and illegal characters because they don't start any characters. So ABC has this operator, this vertical bar operator, which takes the first n characters from a string. So, for instance, dishonest length 4 is the word dish. So, string length 1 is the first byte. String length 0 is an empty string, and so start there being my array of characters. I just say, I take the first character, string of length 1. I use that as the index of my array start, and then so that tells me the length, and so string of length of that is the next Unicode character. So in fact, oh, and if it's an empty string, there was an encoding error in the input. So in fact, you can do Unicode without bit twiddling. And that was my aha moment, because it's always described as bit twiddling. But in fact, you don't need to do bit twiddling to get Unicode characters out. Okay, so that's the end of my first digression. So now back to ixml. So the purpose behind ixml is to get other things than XML into the XML pipeline. Now, here's just one example of how I've used it. For DocBook, the bibliographies are quite hard to encode properly. And so I just wrote ixml that takes a text document such as that, which is the description of the ixml specification, puts it through an ixml grammar like this one that says that a bibliography is a number of biblio entries, and a biblio entry is an abbreviation, and then either an author or an editor, and so on and so on and so on. And so then I get this out at the end, and then I can just put that in my DocBook document without having to do all that coding work. But the idea of ixml is to get stuff into the XML pipeline that isn't XML to start off with. And so one of those things that reads XML is, of course, XForms. And so I thought, oh, well, okay, let's start using ixml and XForms. And so why not make an XForms app for browsing the code of the ixml implementation using ixml? So that's exactly what I did. So I convert the code to XML, and I input that XML into the XForm, and then I can browse it. So this is what the code looks like, the textual code of the implementation. So this is, we're just looking at one of the how-tos here, one of the procedures. Just like Python, it uses indentation for grouping, which actually means it's not context-free, which makes it harder to parse, but we can still do it with ixml, but only to a fixed depth. But I mean, that I chose a maximum depth of 10, and that was fine. So here, the first two lines there are comments, and then you've got the heading of the how-to, and then you've got several lines. And in fact, this is the top level for the processor. Grammar ixml says parse the ixml grammar and put it in G. G being the structured version of the grammar. And then we select if G isn't empty, which means the parsing has happened okay, then we initialize the input, and then we parse the input with G. So we use that grammar for parsing the input. And then if there were no errors in that, we serialize the result as XML. And otherwise, we just write the word failed. So that's the top level procedure for the whole thing. Here's the ixml for ABC. I'm not going to go through it in detail, but it says that my input is documentation, optional documentation, followed by a how-to repeatedly, and then possibly documentation right at the end. The documentation just recognizes the backslash, which is the comment character in ABC. And a how-to starts with the word how-to, and then has a header and possibly a comment, and then a body, and then a refinement, and then possible blank lines, and so on and so on. So this is what that same how-to now looks like coming out. So there's got that bit of documentation at the top that says it's the ixml system, and I've got a date there. And then the how-to, which has its header, and then a number of lines at different indentations of the program text. Fairly obvious, but now we've got structured data, and now we can feed this into XForms. So how does the XForms use that? Well, the code's read in two stages, one for each part, which you saw me selecting when I went from one to the other, and then we display it. And if you were at my tutorial yesterday, you will recognize some of these techniques here. So a repeat ref equals star, that is, I just take every top level element, and that's either going to be a how-to or documentation. So if it's how-to, which is what that group there selects at the top, if it's a how-to, then there are two cases, one for just displaying the header and one for opening it up, which you saw that technique yesterday, for displaying the header and the contents of that how-to. And then there's a similar treatment, a similar group for the documentation. So so these two cases, the closed and open. The closed one has a button that just displays the header as its label. And if you click on that button, then it toggles the open case, and the open case looks just the same, except it's now got a repeat underneath it that takes each of the descendant elements of that how-to and displays it as a line with a possible optional comment after it. So the display is very, very simple. I added a search in, so essential part is the search interface. And so I just have a single line that inputs a queue for searching. And then I change that top level repeat so that it only repeats over elements that contain the search string. Simple and effective. So now we go back to the demo. So here you can now see it. So here's where I switch between the two different versions. It's actually just reading two different files at this point. So this is what you're seeing here is reading a file with XML in it. So here you see documentation, which I display in red. And here you see the different how-tos. If we go to the early one, then this is the one that we've been looking at in the slides. And here's the search interface error, and then it shows me just which how-tos have used the word error, so that if I'm looking for a particular variable or error message, then that's easy to do. And that's about it, really. I think so. I'll go back to the slides now. So clearly, there's nothing in that that's essential to ABC in that browser. All there is folding sections of two types. And each fold consists of a header and a number of lines at different indentations with optional comments. So it would be easy to adapt this by changing the abstraction suitably. So to browse anything at all. So it wouldn't be hard. The only thing then you would have to do is write a bit of XML that produced the right format for my browser, and then this would work on anything that you can run through ixml. So basically, we've got a quick and easy code browser that will work for any language, really. So I use three different declarative languages there. So ixml, it was 29 lines to produce the ABC. I mean, I didn't try to make these as small as possible, so I'm just reporting what it came out as. It's 87 lines of XForms and 25 lines of CSS. So my conclusion is that ixml makes injection of unstructured data into the XML pipeline very easy. And declarative languages in general make life very easy. Thank you. So we have lots of time for questions.
Is it worth mentioning that I think they've added a function to Qt4, so the perspective XPath4 for calling invisible XML?
I didn't know that, but that's delightful to know.
Call it, you should know in the future, be able to call it directly from XSLT or XQuery.
Fabulous.
XForms or whatever.
Yeah, it would. I mean, that will be the next step, is to make it a part of XForms. Yeah.
Well, of course, it's for XForms to keep up with this expansion of functions that's going to happen in 4. Would you know, is there shouldn't be time for an XForms 4.0 when XPath 4.0 is released.
Oh, I see. Numbering the XForms so that it matches the version of XPath.
Mm-hmm.
We did think about that, but what we did was we just separated the two so that we don't specify which version of XPath is used, just to make life easy for so that we don't have to produce new versions every time. But it's true, XPath is absolutely essential part of XForm.
There's somebody on the Zoom. Sid Baumann, please come in.
Good morning. Thank you very much, Stephen. That was delightful. One of the most compact and comprehensible UTF-8 explanations I've encountered. But I was hoping I could get you to back up to the slides before the UTF-8 with the demonstration of the flowchart for ixml processing. I was a little confused at what the structure of the documents are that are the triangular documents at the top of that chart. I have to admit I didn't quite understand that. I wonder if I could poke it a little more.
It's a very good question. And oh, okay, there we go. So you mean, are you still there, Sid?
Yes.
Oh well.
Yes, I am.
So I think you mean this diagram. Okay, so let me tell you a little bit more about the philosophy of ixml. That it's the upper level is invisible markup, not necessarily invisible XML. Invisible XML is just one of the possibilities of invisible markup, and the one that we're working on most at the moment. So the ixml processor identifies the structure of the incoming document, and it can do anything it wants with that result. It doesn't actually even have to produce it as an external document. So it could be an initial phase of any XML processor that just serializes it into memory. But you could also produce one, and somebody already has, serialized to JSON or serialized, I don't know, to CSV. Anything that's sufficiently structured, you can serialize the structure that you've recognized. So there's nothing essential in this process that's hardwired to XML. So in my first, so I'll go to the next slide. So for me, what I do, it's an ixml, a specialist ixml processor there, the one that's marked parser, that doesn't serialize to XML, but serializes to the data structure that the parser I use in the ixml processor expects. So it serializes directly into memory, and that structure is directly useful for the parser. So that's why I say they're structured document, and I don't necessarily say XML document, because there's nothing that requires it to be an XML document. You can modify an ixml processor so that it produces some other structure that's useful in another place. So you've got a lot of freedom, but we are essentially at this moment, ixml produces XML because that's the place where it's most useful. But again, it doesn't have to produce a physical document. It could produce an XDM, for instance, directly in memory that was directly usable by the next processor.
Next stage. So how similar are the parser?
Question, and that I understood your question, Sid.
Thank you. How similar are the parser and the ixml processor? I mean, besides the fact that they're both represented by circles, do they have any other similarities?
Well, I mean, there's nothing to stop them being both exactly the same. and that might be a change that I make later on. I mean, in my case, they're very different, those two. But there's nothing to stop you using the real ixml processor and in that first stage.
So that'd be a sort of eating your own dog food approach.
Yeah. And I believe that the other implementations, well, I know that John's doesn't, that uses the same, John Lumley, who's also on the screen there, he uses the same diagram as me, as it were, with a specialist parser. But I suspect that Norm uses the ixml processor as the first stage in his implementation.
Thank you very much.
And he's agreeing that that's what he does do.
So now we are seeing Norm, Sid, and John, so you can all talk together.
Well, I can confirm.
And John and Norm are two implementers of ixml.
I can confirm that my parser, basically, there's a handwritten parser that parses the ixml, and then that produces effectively internal classes which are used to drive the early parser that parses the input. But it is possible, and one of the tests is to basically parse the ixml and then use that as the grammar to parse the ixml again, and you should end up effectively with idempotency through that system.
Yeah, right.
And that works quite well. But there's also a sense that the ixml is sufficiently simple that you can, by hand, construct the XML version of its own parse, and then you can use that to drive initialization of your parser, all the classes that you need inside the implementation of your parser. So in one sense, the original bootstrap can be done by hand, which is what was originally done, and it's sufficiently simple. And then you get into a system where you've basically now got a description which initializes the parser that you're going to use to parse the input text, whatever that happens to be.
That's essentially what I do. My implementation constructs the parser from an XML representation of an ixml grammar, starting with an XML representation of the ixml grammar. But if you feed it a grammar, it uses that parser to produce an XML representation of ixml, and then uses that XML representation to construct a parser for that grammar, and it's just turtles all the way down.
Yeah. So. Oh, you can't see. Well, no, you can't see my slides. But yeah, so I had two example, and I said the process with the bootstrap, and I said mine was special. And so the process with the bootstrap is basically Norm, and the special one is basically mine and John's version.
Okay. Well, thank you very much, gentlemen.
What else?
Anyone else? We still have 7 minutes and 57 seconds.
Well, we'll just slowly move on to the next speaker then.
All right.
Thank you very much,
Okay.
Stephen Pemberton.